Hey guys, so one of the core question that developers move into TypeScript, mainly JavaScript developers, what is the use of this interface? And today we are going to take a look how we should use these interfaces, or how we should start using these interfaces using the minimal effort, but where it's really impact, or we have the high impact in the code. So the main point is, guys, we know in the object-oriented programming interface we use like implement clauses and having a base type, and then we assign a value of that to the interface type. So many concepts are there. But the main thing we need to understand when we are especially moving from JavaScript to TypeScript, um, that interface, the first use of interface in TypeScript is to capture the data type or define the data type. So why we need to define the data type? Guys, we know in JavaScript we have lots of JavaScript objects we use pretty much everywhere, and we have different shape of JavaScript objects. But how we can ensure that one of the data object adhere to one of the data type? Let's say we have a user JavaScript object, but now we need some way to let the code know the shape of this object is user type. So the first usage of this interface keyword in TypeScript, anyone moving from JavaScript to the TypeScript need to understand that we can use to capture the data type of an object. So if we have a collection of users, we can say this object is definitely adhere to this particular data type. We call it the type definition, and we have another means of doing the same thing in TypeScript using the type alias, but documentation itself recommending us to use interface when we want to define a custom data type or type definition in TypeScript. Alright guys, so what we can do is we can start doing some of the implementation here so we can understand it better. So here we have a pure JavaScript code, but on left hand side we have a TS file or TypeScript file. On the right hand side we can see the playground show us the compiled code into JavaScript. So we can see there's no difference. So it's purely exactly the same look and feel, same kind of implementation, same code, right? So simply, still we haven't used anything or any specific features from TypeScript into this code. So we'll start from this scratch and grow it up by using little features from TypeScript. And guys, this is exactly the way we should try to grasp TypeScript, especially when we are coming from JavaScript background. So further we see the actual value of using TypeScript in our code, then eventually we will get the real taste of TypeScript. So in this code example, let's see how we can use this interface concept to improve the code quality, and at the same time it will help us to understand why we should use interfaces in our code. And also we can find our own definition about interface by just doing this exercise. But one thing guys we have to keep in mind, so interfaces can be used in the concept of object-oriented programming as well, where we use implement clause with the classes. We have the same capability in TypeScript, but first, we need to understand the main usage of these interfaces and the easiest transition from our JavaScript code to use the interfaces and improve our code quality, type safety in our TypeScript. So this is a great strategy, it's a great starting point. Let's keep in our back of our mind, there's another usage of interfaces, which is fairly easy to understand, guys, because it's same as Java and other kind of type safe languages, so we can easily understand those concepts. But in the practical sense, let's try to understand very first how we can capture a type definition for our data using interface. So let's go back to the code and let's start doing and continue this implementation. So guys, while we are doing this code exercise, I suggest you to keep an eye on both sides of the code so you can see what changes we are doing in the TypeScript part and how it will compile down to the JavaScript file. So guys, just remind for all of us, so in TypeScript, what happens is by compiling, it turns JavaScript back to the TypeScript back to the JavaScript, and the JavaScript file is what's the output of this compilation whole process. So we call it as erase types. So it's what it does is simply removing all the type definitions and all the type kind of the added syntax from the final code. So the final code would be just pure JavaScript. So guys, all this effort we are making by using a new syntax, there should be a value, and the best way we can understand whether it's adding actual value is, especially for the JavaScript developers like us, by doing it and see what kind of feedback we would get at the compile time, so we can minimize any kind of runtime errors that potentially occur during running our production application. So guys, what I'm going to do is, first we have this creator function and it's taking a person. That's the way we are doing JavaScript as well. But there is no guarantee what kind of properties will be available in this person. So here we have user, we call just a string, Jane user. So what we can do is, to start with, let's change this to be an object, right? That's what happens usually in our day-to-day code basis. So what we can do is we can give user a name, and we can also just provide an ID. Access a particular property, in this case name, but to keep this going quickly, let's try to access something not available in this object property and see what would be the feedback from this TypeScript file and what would be the output from the JavaScript file. So I change now code to. So guys, before we move ahead, we'll fix this the bug we have here. So we are printing out user. What we want to print out is result. So let's change that and let's run the code. And now we can see, since we are accessing a property that's not in this user's object, we get the undefined. So guys, now the issue we have is in JavaScript, we see that error when we run the application, not at compile time. So guys, at this point, we can see it's undefined. Now we want to see, it would be nice if we can spot this one while we are at the compile time rather than run time. So here the magic happens in TypeScript. We can make this code, we can change it using TypeScript syntax in a way that we can get feedback at compile time before running, that there is a possible error if you run this code, since there is no property called age in the user object. But as of now, since person, the parameter, is not tagged with any kind of a type, TypeScript doesn't know what would the type of that. And in TypeScript world, we call it has any type, same as JavaScript, guys. So it's similar to us, like it's just act like JavaScript. So now we don't have that any type information, so a TypeScript can't give us a feedback. Now here the beauty comes with interfaces. Now if we had here a type definition tagged for that parameter, then TypeScript can help us by spotting this error at compile time. So how we can get a type definition for these user shape objects? It's very simple, guys. So what we have to do is, if you go and check here, it's already inferring the type saying name and ID with some type information. So what we have to do is we just copy this type definition we see here, and then we can use the special keyword interface, and then we can give it a name, a type name, and we can use that type information here. Now we have a type definition for user object, right? But still, TypeScript doesn't know that person would be the user type. So we have to do another step to let know TypeScript this particular function person parameter is type of user. So at this point, guys, as JavaScript developers, now we can see there is a clear point why we need to use some type annotation, because now we saw there's a runtime error in our code, but if we have like thousands of lines, then it would be difficult us to spot that this property is not exiting this person parameter. But that could possibly stop if we use TypeScript. So now we have an interface type called user, and we have some type information there. Now only thing we have to do is go back to that function and tag that parameter with this new type definition user. And guys, the key point is we use interface keyword. So this is the use of interface, and also a good use case why we need interface to avoid this kind of runtime errors. Now let's go back to the code and tag this person parameter with the new type definition we created using interface. So we take this user type and we annotate this parameter with user. Now guys, TypeScript gives us feedback that property age does not exit on type user. Now guys, this is the key point of using interface. Now we can see the value. Now no longer we have to wait till running the code to see this undefined error. Now it's been spotted by TypeScript. But how? Because we defined a custom type for our object, and we use that type to tag our function parameters. So that's it, guys. It's simply now we created an interface, and we can see the syntax is very simple. It's interface with a name, and then just rather than we just giving the values of these properties, we define the type, and we found a shortcut as well. So if we have the shape of the object we want, we can simply use the type inference facility of TypeScript to grab the data type, and just what we have to do is use the interface keyword and give it a name. And guys, that will simply stop us accessing the properties not available there. So here we can now change the name so that's something available. And not only that, if you now see, you can see the code completion. So guys, let's see the JavaScript compiled version of this file. So if I go to the JS tab, you can see, so when it compiled down, we no longer see the user interface type we created, and also there is no type annotation. Those all types information got erased. Right guys? But the key point is, even though the type parameters and things erased, we know that at runtime it will have access to the right properties, because we spotted any errors during the compile time and we fixed them. Isn't it valuable, guys? So now we, as JavaScript developers, we can decide, is it really worth spending some extra time adding these extra syntax that TypeScript provide? I mean, answer is obvious, guys. So that's it, guys. So interfaces, the main use. This is the best value we can use in just one concept of TypeScript, and then use that in our existing JavaScript code. And convert that to TypeScript. And pretty much, guys, we can get a nice safety net of types and strong type definitions. I mean, strongly typed language. TypeScript is strong type language, and we get all that value just simply using this type annotation, parameter type annotation, return type annotation, and if it is necessary, variable type annotation as well. I mean, usually we don't do variable type annotation because it's type inferred. There is a hardly need of that. But saying that, having it in functions like we used here is really handy. Alright guys, so I hope you found this helpful and also you got some valuable input why we need to use interface, and also found your first definition, your own definition, what is an interface in the context of TypeScript. And just to remind you, back of your mind, always keep in mind there's another place that we can use interfaces when we use with the class system, object-oriented world. But guys, this is the starting point. The object oriented concept, I'm pretty sure you will easily grasp that knowledge because it's very obvious. But this usage is a little bit, you feel, most of the JavaScript programmers, they feel what is the value, and especially we are using a kind of the interface keyword, and we expect that interface will always goes with the class implements clause. But you can see it's not always the case, and we have more handy ways of using that in TypeScript world. Alright guys, so thank you for watching the video, and we'll catch up again the next time with another valuable TypeScript tips and tricks. Cheers guys.